Yapalingana. Welcome to the University of Tasmania's Richard Jones Memorial Lecture. It's part of our Island of Ideas public lecture series. This started some time ago, I believe at the beginning of the pandemic, to keep people engaged in all sorts of topics that are important to the Tasmanian community and beyond. But firstly, as a reflection of this institution's recognition of the deep history and culture of this island, the University of Tasmania wishes to acknowledge the traditional owners of the land, the Palawa people, and custodians of the land upon which we meet, and pay respect to their elders, past, present, and emerging. Now, Dana and I did just both comment that we haven't actually done anything in public for some time, so you might have to bear with us if we get things a little wrong. I would like to acknowledge MLC Rob Valentine. I saw you come in. Rob is here this evening, and Sergei Green is also here, a previous chancellor of the University of Tasmania, and a strong champion of Antarctic and all things Antarctic. So my name is Corey Peterson. This is particularly relevant to me. I spent about 16 years working in and around Antarctica, including 3 winters from 1992 to the late 90s, and then worked in the marine program for some time. And that was the U.S. Antarctic program. So it's really nice to be here in Australia. And I have been over the past 23 years. I've lived in Tasmania to become more and more aware of the Australian Antarctic Division and working with them as well. So I also have connections to the Richard Jones Memorial Lecture and the Richard Jones Memorial Committee. I am a member of that as I was president of Sustainable Living Tasmania for a number of years as well. So there's some good connections here for me, and I'm very excited that this is my debut back into the public sphere in some ways. So this evening we welcome both an on-campus and an online audience, and don't mess with the curtain if you happen to walk past. The camera is up there for our online audience, and they will be there. I think we have a couple of hundred people online, as well as who's here in the room. We hope that you'd find tonight a rewarding experience, and I think you will. Our speaker tonight has we've been sharing a few little stories, wonderful experiences in Antarctica as well, and she's quite a champion for that space. The Island of Ideas commenced last year, as I said, and it was just really to keep people engaged with one another, because we know that health and well-being is incredibly important. I'm the Associate Director of Sustainability at the university, and health and well-being is part of our holistic agenda around sustainability. So this program continues into 2021 as a mixture of online and on-campus events. And we do acknowledge that the safety of our students, staff, and community are our highest priority. So I assume that you've all checked in with the COVID safe check-in and sanitized your hands and just be COVID safe as you leave this evening as well. So each year the university presents hundreds of lectures, forums, seminars, and workshops to nurture the ongoing learning of our students, alumni, and the wider community. And many of you I've seen in many Richard Jones Memorial and other lectures, so it's lovely to see you back. Over the last 18 months, over 25,000 community members have participated in our Island of Ideas series, so it's a really worthwhile endeavor that we've taken on. These are a very important part of our role, and this is one of those lectures. So, of course, housekeeping. Toilets are down the stairs to the side if you need them. For those of you online, your microphone, camera, chat function, and raised hand function have all been disabled, so our speaker is not interrupted. However, when we get to the Q&A session, I'll be using my mobile phone to look for online questions as well as what's coming from the audience here. We do encourage you to use that Q&A function on the app. For those of you here on campus, you'll have an opportunity to ask questions. As I noted, I'll try to go every other one so that the people with the microphones can make it around the room. Do raise your hand, and I'll try to make sure I get an order to it if I can. Let's see, COVID safe, I've talked about that. This lecture is being recorded for later access on our YouTube and SoundCloud channels. Now, about tonight's talk. So the late Richard Dick Jones made an outstanding contribution to the environmental awareness in Australia and beyond. He played a pivotal role in the Lake Pedder Action Committee and in the formation of the United Tasmania Group, which is the world's first comprehensive Green Party. And that was in the early 1970s, both of which were groundwork for the later successful national campaigns to prevent the damming of the Franklin River and all sorts of activist campaigns that have grown internationally since then. Dr. Jones was also instrumental in establishing the community-based Tasmania Environment Centre, now known as Sustainable Living Tasmania, which I mentioned earlier. He played a leading role in converting the Australian Conservation Foundation into one of the nation's most dynamic environmental organisations, and is leading lots of different activities even now, including Remade Australia campaign. Further, in establishing the Postgraduate Centre for Environmental Studies at the University of Tasmania, Dr. Jones did much to promote problem-oriented interdisciplinary environmental research that has provided the community with valuable information and innovative ideas. Colleagues, students, graduates, and friends from the Centre for Environmental Studies at the University of Tasmania, in conjunction with the Tasmania Environment Centre, now SLT, established the Richard Jones Memorial Trust, following a community appeal, and it's administered by a volunteer committee of academics and community members to put on this series. We try to do it at least every year, and you can contact the committee directly, contacting the University of Tasmania, but through Sustainable Living Tasmania. I would like to acknowledge that Dr. Jones's family is here, Patsy's here, and various members of the family. I think there's some grandkids, kids, got the whole group there, which is lovely to see you. Now, tonight, we have Dr. Dana Bergstrom. Dana, I think, is going to give a very fantastic and interesting talk based on those slides that came up earlier. And her title is Antarctica Valued, Protected, and Understood. And it personifies her vocation. She is an applied Antarctic ecologist who for decades has championed evidence-based conservation science in biodiversity, biosecurity, and impacts of climate change. She's skilled at science translation and distilling complexity, recently led the exploration of ecosystem collapse from Australia's tropics to Antarctica, delivering innovative options for modern conservation. And if you had been listening to Breakfast Radio or Radio National, I can't remember what I was listening to, where she was announced as the 2021 Eureka Prize winner in Leadership in Innovation and Science, and that was just a few days ago. Would you please welcome Dr. Bergstrom?
Good evening, everyone. It's an absolute pleasure to be here and give the Richard Jones Memorial Lecture. Double click. We haven't done this for some time, and please be patient for me while I get used to this. We should be starting. Okay. I want to start by asking a question. Have you ever been to somewhere that is so beautiful it hurts? And many of you are from Eureka, Tasmania, and so you recognise those concepts. But 14 days sail south of here, there's somewhere that's very, very special. A special
Antarctica,
place.
it's a special place.
Because it's such a special place.
It's just a special place.
It's a special place.
An amazing, gorgeous place. I also love it.
I absolutely love the place.
Antarctica is the most beautiful place on our planet.
I just get this amazing peace. It's extreme, it's unique, it's beautiful.
And it is. I'm one of the luckiest people on the planet. My vocation is to value, protect and understand Antarctica. It just happens to be my job. It also happens to be the purpose of the organisation that employs me, the Australian Antarctic Division. And so I started to ask myself, why is Antarctica important? And being an organisation which has over 300 people, I thought I'd ask them too. And so what I'm going to give tonight is a series of vignettes about those answers. I did a vox pop. I was on the other side of the camera. Tell me what you think about Antarctica. What's important? So it might be a bit disjointed, but let's see how it goes. So why is Antarctica important to you?
Why is Antarctica important to me?
Is a really big question.
And I couldn't answer the question straight away because I was thinking about something else.
It's a huge question.
What happens in Antarctica is so important for the rest of the planet.
For its natural values, pristine geology and landscapes.
It allows us to understand the Earth's life cycle.
Did you see the flutter of the eyes of a scientist at Pristine Geology? Toby's in the audience today. So I'm an Antarctican, and Antarctica is the centre of the planet for me, and you can tell by this map it is. It's an unusual projection of Antarctica, and those red lines shows that people have been visiting Antarctica significantly over the last 5 years. It's a map of every ship travel and every airline or every flight for the last 5 years. And it shows that a lot of people have been travelling to Antarctica from the 5 gateway cities, of which Hobart's one of them. But there's also been a lot of travel from other places, such as the Northern Hemisphere. Many Antarctic programs have bipolar activities. But what about the issue about it tells you about how the Earth evolved and important geology? Well, it really is a great place for geology. The Vestervold Hills, for example, where we have Davis Station, has base geology over 3 billion years old. So 2/3 of the life of the planet we can see in rocks in the Vestervold Hills. I want to go back a little bit younger. I'm actually coming forward. I want to talk about Gondwana. So Antarctica was part of this supercontinent called Gondwana. 150 million years ago, you can see there and see how our continents that we recognise in the southern hemisphere connect together. And the little black dot is the South Pole. So Antarctica 150 million years ago was further north than it is now. And bits of it was beyond the Antarctic Circle. And then the continent started to break up. But around 150 million years ago, in South America, a group of plants evolved called the Poales. And then they spread out across Gondwana, through Antarctica into Australia. And in Australia, they evolved into what we call the Poaceae. Poaceae are our grasses. The poales are down here, includes bulrushes today, sedges, and other what we call taxa, other groups of plants. But Poaceae, the grasses, evolved in Australia, went back through Antarctica and spread out in the rest of the world. They also went from Australia up to through Papua New Guinea, and these pictures on the right show where we find the wild types of rice. Rice is a grain, rice is grass. Came from Australia and they came from India. So one of our major sources of food, rice, first came from what's called a progenitor, an old type plant that evolved in South America, moved across through Antarctica into Australia. Australia, the grasses grew, the grasses evolved, and one of them was rice. Corn is also a grass as well. So why is Antarctica important? Well, it feeds a good chunk of the world in terms of its evolutionary history. Now, moving through the evolution and the split up of Gondwana, I thought I'd show you 65 million years ago. We can start to see how the continents are starting to split apart. The picture here on my right, the all bright colours, shows the magnetism and how the continents are connected with regard to magnetism in the Earth. And here in the bottom two pictures, you can see Australia, Antarctica, and an entire continent called Zealandia, most of which is now underneath the ocean. But in there is where New Zealand and the subantarctic islands of New Zealand, the Campbell Plateau. But we can start to see some fracturing happening around Australia and Antarctica and Zealandia at 65 million years ago. What it looked like was this. It was a temperate forest going up to some alpine areas, and things that we would recognise today if we've gone down to the Tasmanian Botanical Gardens. Araucarias, monkey puzzle trees. Things we'd recognise if we go bushwalking, Nothofagus, yew and pine. And this was in Antarctica. It was a temperate condition 65 million years ago, just a bit darker than it is here. But there were dinosaurs, and there were also birds, both those in the trees and on the ground, and scurrying around were the beginnings of mammals. But as we know, things changed. So looking at the moment, it's still about Gondwana splitting up. About 45 million years ago, South America started to break off, and what's called the Tasman Gateway between New Zealand, Tasmania and Antarctica started to form. So the continents are starting to separate, and there was some volcanic activity. The KP in there stands for Kerguelen Plateau, had some volcanic activity, and this is the origin of our third island in the subantarctic. So the picture on the right, you can see they're starting to get some passageways between Tasmania and Antarctica. And by 30 million years ago, then, whoops, go back, this happened. All the continents had separated. Now we have the Southern Ocean, and it is the biggest ocean waves on the planet. The reason being is that nothing stops it. The waves go round and round. There are no bits of land jutting out. I sort of guess goes between the Drake Passage, but the biggest waves on the planet are found in the Southern Ocean. And that allowed a major change in Antarctica, frankly, the cooling of Antarctica. I'm getting seasick just looking at it. Okay, now the concept of engine room of the planet.
It holds all the secrets, the climate that we really need to understand for our future resilience.
What happens in Antarctica affects the world.
It's very important in terms of the global climate system.
Affects all of us everywhere in the world.
It's important for our food security.
Because it's important to the world. It's important to the health of the climate and the ecosystems, not just around the Antarctic itself, but also more widely.
Antarctica is the engine room of global climate. It's important for our climate future.
It also, by the way that the oceans and the atmospheric circulation connect, is essentially the engine room for the climate of our planet.
So Antarctica profoundly influences our climate. What does engine room of the planet mean? What they're mainly talking about is what's called the meridional overturning circulation, or the ocean conveyor belt. And this is a system where cold water sinks to the bottom of the ocean floor and moves northward if you're coming from Antarctica in the winter, or comes southward from the Arctic in our summer or the Northern Hemisphere winter. And surface waters move further south or north, depending on where you are in the hemisphere. It takes about 1,000 years for water to move all around this circle, but it connects all our ocean basins. And what it does is it dissipates heat from the tropics, and it brings up incredible upwellings of nutrients from Antarctica. So here's an animation. The white is on the surface, the blue is deep water coming away from the continent. And the critical thing about this ocean conveyor belt is it relies so much on the formation of sea ice in winter. So here we can see the Antarctica expanding as the winter sea ice expands, about 3rd time more in terms of surface area than in summer. And the thing about this is that creates one of my favourite terms, the Antarctic bottom water. So in winter, it's cold on the plateau of Antarctica. Cold air, as we know, as we're below Kunani here, cold air sinks and it comes off the plateau and it blows out and it cools the water off the coast of Antarctica. As it cools, it forms sea ice. Sea ice is fresh water, and what happens is the salt gets dispelled and then the water under the sea ice is heavy, it's dense, and it sinks. And when something sinks, that is a pump. So when they talk about the engine room, we're talking about a pump of cold water, dense cold water that sinks to the continental shelf of Antarctica and then starts to flow. And that is the pump, that is the engine room of our climate. In summer, the same thing happens up in the Arctic. So the two systems are really important. And in terms of climate change, when we start having melt coming off, we won't have as much salty water. We won't have the same strength of the pump. So that's the main thing about why it's the engine room. The other thing is about the direction in which winds move. They move west to east, and we talk about the furious 50s and the screaming 60s and the roaring 40s. Winds west to east coming around Antarctica. And the EAIS is East Antarctic Ice Sheet. Just north of that is where we have cyclones forming. They're not tropical cyclones, they're Antarctic cyclones. And they can drift north. So when we have an Antarctic blast, it's cold air directly coming from Antarctica, delivering snow to southeast of Australia. Cold fronts are cold for a reason. Now, my next thing is the last great wilderness.
Antarctica is the last great wilderness.
The most remote and inaccessible part of the world.
It's one of the most incredible and spectacular wild ecosystems on the planet.
We've got this new concept of eco-grief. To counter eco-grief, we have Antarctica, which is the last true wilderness in the world.
And it is an entire continent covered in ice. So it's a really important concept. And it's a concept to most people on the planet. And the thing is that most people don't actually get to go to Antarctica. Back of an envelope calculation, I estimate less than 1 million people in the entire history of humans have seen Antarctica. So most of our concepts of Antarctica is this wilderness, and it is. So what about it? What about us in Antarctica? Well, it turns out colleagues from the University of Tasmania and myself have calculated the human footprint on Antarctica, and it is tiny. 22 mcgs. That's when you add up all the disturbance caused by humans in Antarctica. And that's 5,000 buildings. Sean Brooks, Dr. Sean Brooks, but then a PhD student, measured every single building in Antarctica using Google Earth. He's a very patient man. He also calculated the ice-free areas in Antarctica, or recalculated, and it came to 0.4%. It's smaller than the size of Ireland. And the bits, the 5 kilometres close to the coast, is 0.06%. So we have these tiny ice-free areas, and there's a problem with that. I should point out the little red dots are where there are buildings, but that's not to scale. It just shows you where they are. But the thing about where we want to be is also where we find life. And when you have life and you have other humans, we have conflict. And this is one of the things that we're always trying to reduce, is that conflict where humans are activity in Antarctica and where wildlife exists. But wildlife is seriously important to
the wildlife's unique.
It's wildlife.
Antarctic
wildlife.
I was thinking about the evolution of giant petrels, actually, which just happen to live in Antarctica.
So I was
provides
thinking
great
about
habitat
something.
for the seabirds, including the penguins, so that they can breed there and then they can feed in its productive waters.
It's a place where animals and plants are actually living with minimal human impact.
That's the point. Animals don't care about humans. We're just at most this thing to look at, and maybe sometimes an irritation, or maybe we can cause disturbance, but we try and avoid that. So we have seals, we have seabirds, and then we also have the little things growing in mosses and in lakes and things like that. I want to talk about these creatures, penguins. What I want to get across is extensive age. 65 million years ago, we've looked at this map already, and an asteroid hit the planet up near Mexico. Huge amount of dust came into the sky. The skies went dark. Dinosaurs lost their food, they lost their trees. But the thing that most people don't think about is that, okay, dinosaurs died out because they lost their food, but we lost their trees. There was a massive death in birds, particularly birds that relied on trees at the time. And it's those birds that were ground-based that so much of the birds that we have today have now come from. And about 61 million years ago, we saw the first precursor of penguins. This is Waimanu. It's a fossil from New Zealand. And you remember the map, Australia, Antarctica, New Zealand, very close. So penguins have evolved from Australia and New Zealand areas close to Antarctica. So the precursors around 61 years, and there was a gap. There were no dinosaurs in the marine system, and nature abhors a gap. So there was massive evolution of penguins. So there's been many, many penguin species that have evolved and have become extinct. Far more than there are today. There's less than 30 species. Those top ones are our Antarctica, subantarctic things. When we follow the blue dots down, we'll see that the oldest penguin is about 15 million years. It's the little penguin from Australia, followed by the Adelie penguin. So Adelie penguins have been around for over 10 million years. We're just newcomers to their existence. However, one of the really sad things came out last week in a seabird conference. All our penguin species on the planet are now threatened by climate change and human activities. So 61 million years of evolution is threatened by our activities, which is sad. But thinking about the gap, there was a big gap, about 20 million years before the evolution of whales and even more before the evolution of seals, and the penguins went right. And they were very, very big. Some of the penguins were the size of humans. And now we find that there are penguins and other seabirds all around the coast of Antarctica, and we've defined them as what are called important bird areas. But our climate is changing, as
we're living
mentioned.
in the Anthropocene, and we're seeing changes to the planet that we've never seen before. The future sustainability of the planet is in peril.
And let's put this in context. This is a 56 million year record of climate change. But what's there is carbon dioxide. And what we know from our ice cores is that carbon dioxide and temperature match each other. So if we're looking at a CO2 trace, we can also infer temperature. And so if you follow the grey line at the top, you can see that in what's called the Eocene, between 50 and 40 million years ago, Antarctica was completely unglaciated. And the mean CO2 was about 600 parts per million. We're at 400 parts per million already. So 600, 200 parts per million difference Antarctica completely ice-free. And then it got even warmer. But then, as we've gone through 300 or 30 million years ago, the Southern Ocean formed, it started to cool. There's also another element to cooling and the interglacials, the greenhouse to icehouse, and that's to do with the orbit of the Earth around the Sun. I just want to look at this track. So around 30 million years ago, the ice started to form on East Antarctica, and by about 10 million years ago, the West Antarctic ice shelf had formed. And then we went through multiple ice ages and greenhouses in the more recent evolutionary times, including over the last, I think it was 125,000 years ago, there was a marine ice shelf collapse on the western side of Antarctica. So there was connection between Antarctica. Happened very, very quickly. So we've seen ice loss in Antarctica very, very quickly. So we know what to expect. Let's have a look at what ice looks like today. So the top pictures show the thickness of ice over land in Antarctica. The top one is the East Antarctic, which is the bottom right-hand stripe, and then the bottom one is the transect on the left. That's through what we call West Antarctica. So the features is that in Antarctica, the Dome A, over almost 4,000 metres in height, and we're looking at between 1,000 to 2,000 metres thick of ice. And there are mountain ranges in Antarctica that we don't see. They're under ice. And there are also subglacial lakes, complete with liquid water. Lake Vostok is the deepest of those, and that was sealed off from the atmosphere about 35 million years ago. Now, to the right of this picture says marine ice sheet, and if we look at elevation, a good chunk of the rocks that make up Antarctica are below sea level, and that's really critical when we think about climate change into the future. If we look at the West Antarctic, you see most of the land is under sea level. A lot of it is from the weight of Antarctica, ice, just pressing it down. And often you can get, when we have interglacials, we have what's called isostatic rebound. The land rises because the weight of ice is going to, but a lot of it will remain below sea level. The picture, the pretty one on the left, just shows how ice is flowing a very, very slow river across the dome of Antarctica. But if we have a look at the next picture, the picture on the left shows what is actually the Antarctica looks like under the ice. We have a continent to East Antarctica, and the West Antarctic with the peninsula is actually an archipelago. And good chunks of it are just ice. And on the right, it shows changes in ice thickness recently. And you can see all down the West Antarctic, all the red, been some massive changes to the ice in Antarctica. And this will contribute to increase in sea level. Also, we can see on East Antarctica, the Totten Glacier near Casey Station and the Denman are also picking up changes in the thickness of the ice. It's getting thinner. Ice that's on the continent and then it gets thin equals sea level rise. Changes in floating ice doesn't alter our sea level. And just recently, IPCC put out its latest report, the 6th assessment, and there's been a big change, so much more confidence in what we understand compared to the first IPCC report. We now know that CO2 concentration is the highest it's been in the last 2 million years. CO2 equals increased temperature. We know they move together because of our information from our ice cores. Sea level rise fastest than in the least 3,000 years. Arctic sea ice lowest in the last 1,000 years. Polar bears are really in peril. And glacial retreat unprecedented in the last 2,000 years. I have seen glaciers on Heard Island, or I've tracked them on satellite, from be grounded so dramatically over my short time I've had experience in Antarctica and the sub-Antarctic. So in the lifetime of a human, we're seeing dramatic changes in these places. And the summary is these lines. We're most likely going to see about 1 metre of sea level rise from Antarctica and from Greenland in the next 80 years. So children that are born today will see an increase in sea level between 80 centimetres to 1 metre. That's Hobart waterfront. But these are models, and models give a good understanding, but they don't give a perfect understanding. And one of the things that came out of IPCC, this idea about deep uncertainty. Things can change really rapidly in Antarctica, and we don't know enough yet whether to predict there might be some catastrophic change. In 2001, conditions will have an extreme event in the southern hemisphere, and an ice sheet, one of those things that don't contribute to sea level, but it's called the Larsen B, it collapsed in 3 weeks. A massive ice sheet collapsed in 3 weeks. It didn't change anything to sea level, but what it did is took away the dam, and now the glaciers on the east side of the Antarctic Peninsula are moving a lot faster because there's no dam. Things can move, unfortunately, rather rapidly. And so IPCC said, we've got this thing we've got to look after. And more science will help us resolve that. But one of the things we do know is there's now been an incredible amount of heat actually trapped in the oceans. And that heat is now eating at the edge of Antarctica. So a lot of our glaciers that come out into ice sheets are being eroded by warm water. And if they get to the point where what we call a grounding of an iceberg or of an ice sheet, but the land beyond that is below sea level, we can get warm water going into that space and result in very rapid change in ice level. So there are big changes in Antarctica, big long-term pressures, but there are also short-term pulses. Last year, we reported about a heat wave. It began in East Antarctica. I was in Davis Station and it rained. Rain in Antarctica. It was the most remarkable thing I saw, resulted in some local flooding. By the time it got to Casey, we were in a full-blown heat wave, and we had the first heat wave in Casey Station. We had temperatures over 8 degrees. That's a lot. By the time it got to the Antarctic Peninsula, we were up to over 18 degrees. Penguins were seriously overheating. There was flush of dinoflagellates, big changes. So a short-term event, long-term changes. We've now seen a number of them. 2001 was another time we had a heat wave, for example, in the dry valleys, and they had flooding. So we're seeing long-term changes and we're seeing short-term extreme events. And that is what leads to ecosystem collapse. Okay, moving to something more
one of the only places on Earth that is completely devoted to peace and science.
It's a place of peace and cooperation where we all work together to produce the best available science.
For peace and science.
There are so many species we don't really even understand or know about yet, and so much that is present there that is not anywhere else in the world.
It's a place that we know very little about.
Because it's the one place in the world where people collaborate and do science together.
An amazing environment where you can go and look at various things, from vegetation to glaciers to the animals, and gives us an indication of climate change and what's happening in the world as a whole.
And the most exciting thing happens next Saturday. Noina, Southern Lights. The most exciting platform is arriving on Saturday, so hopefully you can all, if you're in Hobart, you can go out and see it. Antarctica is about natural values, peace and science, and it does actually have this collaborative sense and something very, very special. And Noina is going to make it even more special. The ship is so big, we're going to need collaboration with our science partners from other countries. So it arrives on Saturday. It's got a moon pool, which allows us to tap into the ocean beforehand. The bit I'm more excited about is to be able to go to places that we haven't been to, and so it becomes a science platform to explore the ice-free areas, things we haven't explored. And then comes the concept
I feel like
of
it's one of the
pristine
last
continent.
really pristine, beautiful places. It's one of the places left in the world that is untouched.
One of the few untouched regions of the Earth.
It is one of the last pristine places on Earth.
One of the last pristine places on Earth.
The most preserved continent on the planet.
It remains relatively untouched, but humans have left their mark.
Trust a scientist to change it. Our values have changed since we've been in Antarctica. When we began our stations, we were at a time where you had an incinerator in your backyard, you dump things in your yard. We dump things in our yard in Antarctica. We have a few tips we need to deal with. We've cleaned up one already. And so there's some legacy waste. And then occasionally we have the odd oil spill. But at the Australian Antarctic Division, it's sort of twee to use the word world leading, but we actually are world leading in what's called remediation. We know how to deal with oil spills in Antarctica, and we now give that advice to other nations. We use the microbes in the ground to actually eat hydrocarbons if there's been an oil spill. So we're learning and now applying how to remediate oil spills in Antarctica. And then on top of that, we have a thing called environmental toxicology. Oops, go back a bit. I'm just going to let me. It's a touch screen. Yeah, been there. There we go. Oh, sorry about that. Oh dear, it's not going to do this. There we go. Oh, okay.
It is
we know
so
when.
challenging.
Quiet, Kim. We know when to stop cleaning things. We have a whole range of tools to clean up, and over the next decade, we're going to leave a cleaner Antarctica. Now they're leaving 12.
And huge and robust, yet so fragile and needs protection.
Fighting to protect that and keep it pristine, I think that's a valuable goal.
Presents an opportunity for us to do things correctly and protect it in a way that I wish we could have done for the rest of the world.
As an environmental scientist, I get to correct our past mistakes and leave a cleaner Antarctica.
There's a real chance that we can address the threats to the environment, and we can use our science to ensure that biodiversity is protected and conserved into the future.
Yay, team. I feel so proud that I work with these applied scientists at the Antarctic Division, and we do focus on environmental protection, and the organisation focuses on protection. But we need to acknowledge there's a good reason. We've had, for example, in our last century, catastrophic mismanagement of whales. I want to show you how environmental protection has changed and has developed with Australia in there from day one. So at a time when we didn't use fossil fuels, we used whales as a source of oil. Started with the biggest whales on the planet, bigger than any dinosaur, and the blue whale population was harvested to the brink of extinction. After blue whales, we moved to humpbacks. After humpbacks, we moved to southern rights and then down to elephant seals. But luckily, before they became extinct, maybe we need to stop here. And so in 1948, the International Convention for Regulation of Whaling, what we call the International Whaling Commission, was formed. In 1978, the Fraser government launched inquiries into whaling and whales in Australia, because we were still whaling off the coast of Albany. In 1979, Australia stopped whaling. In 1986, there was a moratorium, a global moratorium on whaling. In 1988, Japan started scientific whaling, and we took them to the International Court of Justice in 2014 and demonstrated that it wasn't scientific whaling, it was whaling. And in 2019, Japan withdrew from the IWC and stopped whaling in the Southern Ocean. It's a really big thing. We use science to defend the conservation of whales. And in terms of environmental protection, it began in 1957 with IGY, the International Geophysical Year. There had been an international collaborative So a year or a couple of years, 50 years before, and we've had one since. In 1958, the International Council for the Scientific Unions established SCAR. It's seriously the best acronym on the planet, but it stands for the Scientific Committee for Antarctic Research, and for a while I was the Australian delegate. It's the scientific organisation that coordinates science across nations. There are 54 signatories to the Antarctic Treaty, first signed in 1959 when it was only 12, so it's grown. In 1961, Robert Menzies held the first Antarctic Treaty meeting in Canberra. In 1964, there was agreed measures for the conservation of Antarctic fauna and flora. 78, the Convention on the Conservation of Seals. 1982, CAMLR. Most of us in Hobart will have heard of CAMLR, but people listening will not have. Conservation for Antarctic Marine Living Resources. It's the best fisheries convention in the world. It's not because it's focused on fisheries, it's focused on ecosystem management. And it's based in Hobart. Every October, outside of pandemics, hundreds of people come from all over the world to talk about the conservation of the marine resources in the Southern Ocean. And in 1989, Australia decided not to ratify a convention of mining, and in 1991, what we call the Madrid Protocol, the Protocol for Environmental Protection, was agreed and ultimately signed into. 2004, another one, Convention on the Conservation of Albatross and Petrels. It's a photo of Bob Hawke and Michelle Rochard celebrating the 20th anniversary of the Environmental Protocol. Last week was the 30th anniversary of the Environmental Protocol, and it operates, it's the focus of my career, and it's about living values in Antarctica and protecting those values. There are also non-living values and also things like wilderness and aesthetics. Now, if anyone was smart, you might have seen some colouring in the little strokes of blue and red. What I want to illustrate is that there's been bipartisan support from governments on the protection of Antarctica in Australia, and that's something that's worthwhile acknowledging, from Menzies to Bob Hawke and beyond. Now, the last thing I want to talk about is the concept of transcendence, and it goes back to this issue about most people haven't seen Antarctica, and Antarctica is more of a myth, something more than a myth, something deep down inside.
It's strategically important to Australia.
That it's owned by nobody.
It's a place where many of our hopes for the rest of the world are the daily reality.
Everywhere is important to me.
Given its capacity to transcend international political differences, its huge contributions to the life sciences and the physical sciences, its role in the protection and beneficial use of an entire continent, Antarctica has created a unique culture which will inspire generations to come.
We need Antarctica, and it's important to me because I need to have hope for the future.
So Antarctica is more than a continent, it's more than living values, it's hope. And it's a place that brings inspiration. And it transcends national boundaries. Australia signed on to the Antarctic Treaty, and it signed on to the entire Antarctic Treaty. And that meant we suspended our claim. And the Antarctic Treaty came out during the Cold War. So it's an incredible symbolism there of nations collaborating, particularly in science. When I was down south last year, we went to a conference in Antarctica in the Lasman Hills, and there was Russia, China, India and Australia there, and we all compared our scientific activities, and it was really, really inspiring. So Antarctica transcends lots of things. And so it is a continent set aside for nature, peace and science. But there's more to it than that. And one of the things I just want to finish on is the arts fellowships that we have in Antarctica and other artists who are inspired by Antarctica. Because it's really hard to explain how significant it is without using our humanities folk, without going into the arts to explain something that is so precious to us. That's where I'm going to leave it tonight. I hope you've liked the little clips and understanding why Antarctica is important. Oh, going back to the beginning now. Let's do it again. I don't think so. It's a very special place. Incredible science is coming out. It's a changing place that will affect us and everyone on the planet. And science will give us guidance as to those changes. And it certainly is giving us signals now that climate change needs our full attention. Thank you.
I suppose everyone can hear me all right. So,
and me too.
Thank you. Excellent. I'd like to, I'm supposed to remind everybody. So remind the on-campus audience to wait for the microphone. So when your hand goes up, make sure you do that. And the people online, so they'll be the first one over there in a moment. I just want to just reflect for a moment on transcendence. I'm glad you picked that one at the end, and you introduced yourself as an Antarctican. I also see myself as that. And it is a unique way of looking at the world, and I might get in a little bit of trouble, so I have my own little anecdote to share. I was at Palmer Station when the Polish government fell, when the communists fell, and the Polish station that was down on the Antarctic Peninsula didn't have many supplies left, and we were going to go past that station, so we decided we were going to raid our stores, stop at every Antarctic station on the peninsula, so there's quite a few nations represented there, and we called ahead and radioed ahead and asked people to start getting their tri-walls, these giant, basically cardboard containers to put on and off of ships. And whatever you had, we were asking, just put it in there. Food preferably was the first thing. And then we contacted our national program and we said, we're going to do this. And they said, no, you're not allowed until the Polish government asks for assistance. So of course we did it anyway, and we had scientific reasons for stopping at every single station, and we did CTD casts and all sorts of things off of every station while supplies were transferred. And then we went to the Polish station, and it just reflected that sense of an international, cooperative, personal connection that we all need to have as global citizens, that we helped each other in need. We did it in spite of official protocol. And, you know, we got a bit sanctioned for it at the end, but other national governments backed us, and so nothing officially happened. But those are the kind of things that I think exemplify what you were talking about there, and science being an example of how you can do that. Could you reflect just a little bit more on your own personal experience?
I'm reflecting on a subantarctic island, which has the same spirit, a French subantarctic island, and a 4 a.m. New Year's Eve, or knock on the hut door. The French pâtissier had made chocolate croissants to take out to all the people working there from all across the nations. And that reflects the individuals, but it also reflects the collaboration that we have across nations. Nations help. We have the French Polis program coming through Hobart, for example. Australia helps France, France helps Australia, and it goes right across to all nations. And so it goes right from the way the stations are run. People care for each other on the stations, and then it moves up to nations care for each other in Antarctica. And I think it's a really important lesson for how the world can proceed.
First one in the room.
Yes. Just wondering, I have been to the Antarctic on the bark Europa, and I didn't get off because I didn't want to leave a footprint. My question is, you call it pristine, you call the fact that it has natural values and it's for peace and science. What is the idea of a 2.7 kilometre long, 40 metre wide, 11,500 concrete block, 10 tonnes each, runway when and that's sort of increasing the human footprint by 40%, with avoidable impacts, meaning you don't build it because you've already got a runway. You've got 20 airports already. You've got Naina, which is 160.3 metres long, 25,500 tonnes, resupply ship. What on earth do we need to have a 2.7 kilometre, 40 wide, a metre wide, 11,500 concrete runway, which increases the human footprint? So that is not respecting natural values. And I have been there, and I know that the penguins depend on the ice-free areas, the seals depend on the ice-free areas. There are heaps of stations. They don't necessarily share everything, because I have been to the Polar Symposium here, and there's a station in the middle of the Antarctic, and nobody, they're allowed to visit each other, but nobody had visited at that point in time. And I've been to lectures where they say, how many times do scientists in each station look at how many times a penguin spews? So do they share that knowledge? But my point is, why on earth would Australia, who believes in the natural values, build a huge runway when it's already got a huge resupply ship?
Thank you for your question. And this is going to be hard to accept the answer, is I can't answer it. I work for the Antarctic Division, and I'm I'm an expert in matters in Antarctica, and as such, I am advising on the Davis Aerostrom project in terms of its science. So I've signed a probity document which says I respect the process, which is a proposal which needs to go through environmental evaluation. So I can't answer your question because of my position of being a scientific expert, which is advising on the process. But it's a process which will be seen through to the end. We have the science, it will be evaluated on the impacts, and that's where the community gets to express their opinion. By being a public servant, I sign on to be a servant of the community, but I also sign on to to provide information to whatever government is in at the time. But I will provide that information in terms of the comprehensive environmental evaluation, and everybody in this room will get to read that, and everybody will have time to comment on that. So I can't argue why the government is doing that. And it's also not proper for me as a public servant to argue that. I just provide support to the government at the day. But it's up to the community to ask questions about any government's activities in Antarctica. And that's what you are doing. So I hope you don't mind me not saying I can't tell you why, but just understand, as an applied scientist, I'm doing my damnedest to provide the best scientific advice to inform the comprehensive environmental evaluation for this proposed runway.
Thank you for that. So we'll take a question from online now, which sort of follows on to that. What are the greatest threats to the wilderness values of Antarctica?
Greatest threats to the wilderness values. I would say the greatest threat to anything in Antarctica is climate change, because what we represent, what we see, will change. When we recognise that all penguins are now threatened, that's something to pay attention to. We have evidence of ecosystem collapse, so I would say climate change. Having measured the footprint of humans is relatively small to the entire continent, but our activities in the rest of the planet is influencing Antarctica.
We'll take one from the room here.
You spoke a lot about international cooperation, a bit in passing, because you're mostly talking about Australia. I had taken it that international cooperation was getting just a wee bit wobbly in Antarctica, and that there was a greater presence of, if you like, national self-interest and whatever emerging. So I don't know whether you're in a position to comment on that, but I did take it that things were getting a little bit cracked.
We have seen that all nations are still applying the values of the Antarctic Treaty. So, yeah, there's discussions. I mean, there's a lot of hawkish stuff in the press. But that's not what we see in Antarctica. There's a lot of people wanting to make their name about being hawkish. China, for example, is still following the Antarctic Treaty. It still participates in the Antarctic Treaty. It participates in CAMLR. So what's on the ground isn't matching what we're seeing in newspapers. Kim Ellis, our director, went on what's called an inspection tour of multiple nations, countries, facilities last season, and was greeted with open arms at every station that he went to, and that included China, Russia, Ukraine, India. We were greeted with absolute courtesy when we went to Bharati for the symposium. So what we see on the ground isn't what we're reading in our newspapers.
Excellent, thank you. All right, another one online. This is a long one. You mentioned despite the careful activity, we still leave behind traces and disturb the native fauna and flora. Why can't we leave the unexplored Antarctica be and focus the effort on climate change so it gives us more time in the future to explore the frozen Antarctic with better technology and waste management, etc.? Or are you feeling we lost the climate change war and trying to study as much as you can before Antarctic ecosystem changes with climate change? Tough one.
Every question's tough. This is a wonderful audience. We are still unlocking information about climate change in Antarctica, and I would argue that science about climate change will help us inform what we do back in the rest of the continents on the planet. We do have a legacy, though, of waste of past practices, and our science allows us now to come up with actions that we can clean it up. So do we leave the legacy waste or do we clean it up? My preference is for us to have a cleaner Antarctica, and that's one of the things that we're pursuing.
Yeah, and I can reflect on that, having worked at McMurdo Station for quite some time, and the nuclear reactor that they had there and all the tons of soil that had to be removed from Antarctica to ensure there was no radioisotope contamination left on continent. Another one up here.
Thanks for your presentation, Dana. As a scientist, can you paint a verbal picture for us of the Westfold Hills and tell us what is unique about it, please?
The Westfold Hills is one of the large ice-free areas in East Antarctica. So we have the Windmore Islands, we have the Westfold Hills, the Bunga Hills, and the Prince Charles Mountains. It's 400 square kilometres, low-lying hills because they're 3 billion years old and have had lots of ice going over them, flattening them, and there's some massive dikes in there. And some of the features that are quite beautiful about are the fjords. And in the fjords, there's some very surprising marine life. There are polychaete reefs that we're just only starting to learn about. So a very beautiful part of Antarctica.
All right, a lot of them are coming in here. I'm not going to sort, I'm just going to read them. Is there a limit to the number of stations member countries can place on Antarctica?
No, there's not, but every time, and station numbers are increasing, but every proposal has to go through the Antarctic Treaty for other nations to comment on. So this year, for example, Australia was asked to look at the proposal for a new station by Turkey, but there's good signs. Like the New Zealand program is not building a new station, it's pulling down its old station and rebuilding a smaller footprint on the same site. McMurdo, the biggest station in Antarctica, the US program, they are going to rebuild to have a smaller footprint. So there's some very nice trends about reuse, reducing the footprint that we're starting to see coming out of the Antarctic Treaty Nations.
Excellent. Thank you. Up over here.
Dana, great talk. Thank you. Congratulations on your award. And congratulations on being one of the longest standing women Antarctic scientists that Australia's had in their program. So well done for that. My question for you is a bit more creative, I suppose. If the director or the minister came to you tomorrow and said, Dana, what do you want to do? What's your next big science question? We'll give you a really, really big budget. What science question?
Oh, yes, please. Kim's sitting there.
I am angling for the job, so, when I get there. But what's your big science question that you haven't had the chance to ask or explore and do? And what would it be?
Two things. I would like Noyena, thanks, Kim. There are many places in East Antarctica that we know nothing about. Most of our work has been station-based, and the new ship allows us to go to places that we haven't been to. So we know a bit about the Windmill Islands, where Casey is. We now know a lot more about what's in the Westerwald Hills, and we know a little bit about Mawson, but there are these places along the east coast that we don't know. There's what we call the wedge, in terms of the Australian Antarctic Territory, just at the edge of the Ross Sea. So there's new areas that, in terms of our knowledge, that'd be really worthwhile exploring, because we don't know about this biodiversity, particularly with regard to nearshore marine, because it's difficult to get there. But a ship with a moon pool. And the other thing, my dream is, it's called ANTOS, the Antarctic Nearshore Terrestrial Observing System. When we talk about climate changing, it's a really complicated story right across Antarctica, and wanting to know how that affects ecosystems. So the vision that we have through SCAR, the Scientific Committee for Antarctic Research, is a thing called ANTOS, Antarctic Nearshore and Terrestrial Observing System, to have at least 20 sites in real time recording climate change and how ecosystems are responding to that. Much of the biota in Antarctica has gone through already multiple glacial and interglacial times. So that ice age to greenhouse. And so understanding how ecosystems can survive through multiple glaciations is really useful, and multiple greenhouses would be useful. And that would also help us understand how ecosystems elsewhere on the planet are responding.
Excellent, thank you. Just realizing the time. We are going to take a few more here, two more from online, I think. Oh, there's so many good ones. Let's see, here we get one. Which scientific issues or research topics does Australia really excel at compared to other countries, and what are some of our greatest recent scientific shares?
Remediation, ecotoxicology. We're certainly world leading in that. We are really good at understanding how sea ice is working, and biodiversity. One of the things that came out of research that we've led is this concept of bioregionalisation. So 30 years ago, Antarctica was considered to be, in terms of how biota was dispersed, you had continental Antarctica, you had the peninsula. What we now know is there are at least 16 bioregions in Antarctica, and each one is separate. And one of the things that I instigated was a thing called Aliens in Antarctica. And it was a program not chasing aliens, green men in. We're looking at how things get hitchhiked into Antarctica. And we have the best biosecurity in Antarctic nations. If you go down and see the Macquarie Wharf, you'll see the best cargo and biosecurity facility. And I can see Jenny Wynnum in the audience here, who's together we're pushed hard for Australia to have the best biosecurity, and the Antarctic Division has, and so we've made it into practice.
And that goes both ways as well. I was in charge of shipping samples off continent, and there's a very clear effort to ensure nothing from Antarctica comes out as well. So that's a very interesting side. You wouldn't have thought that would be an issue, but it well and truly can be. So we've got one more question in the audience here, and then we'll do another online. Thanks, Karen.
I've worked out the microphone, thank you. Thanks for a wonderful lecture, Dana. I was at an Antarctican reception the other night, and a comment was made to me by someone who was present who wasn't in that group effectively, who said, all these people here love to talk to each other about Antarctic things. They know how to do that. But what about everybody else? Do they realize that not many other people are in this club? And do they know that the more people outside of that club will talk about it and care for it, that's where government is going to invest its money. So I'm interested in how, as Antarcticans, we can bring more people across the line to help us out with funding such important science as the science that you've been doing all your career. I've wondered if there's a comment, given that we are all about to leave here and can take something away.
That sounds like a Dorothy Dixon. Here's my opportunity to thank you to talk about the Antarctic Science Foundation, which is an opportunity for people to support Antarctic science. And the Australian Antarctic Program is now putting a significant amount of investment telling people about Antarctica. So if you go on to the antarctica.gov.au, you'll find a significant amount of information about Antarctica. And there are also many other activities happening around. There's the Pure Antarctic Foundation, which is about artists and scientists telling stories about Antarctica. So there are opportunities for people to hear stories and learn more about Antarctica. So thank you for the question. I can see one person up there just waiting.
Thanks, Dana. I just wanted to take this moment to congratulate you on winning the Eureka Prize, one of the highest accolades that can be awarded to any Australian scientist. I see many Antarctic early career scientists in this room, many of which have been directly supported or inspired by yourself. What do you see as the greatest challenge for us, the next generation of scientists, to overcome to support the conservation of Antarctica?
I think one, having a job. We've seen with the pandemic significant decrease in the number of early career researchers having opportunities in universities, and I think our societies are better if we have places which foster early career scientists, such as universities. So funding education, funding research is a no-brainer. Persistence and curiosity is the best things I can offer for advice for early career scientists, is to if you can contribute to a good idea, get in there, because science builds on other people's ideas, and we build up a little bit at a time.
Excellent. Thank you for that. There were some more questions online, so we may save those and put an answer online in the chat. We all just need to thank you for everything you've done and for coming tonight and sharing this. Has been fantastic. So thank you. And we have a tradition here at RJML, and I've hidden it over here because otherwise it would have been too obvious under the chair. Thank you gift for your time.
Thank you very much.
Thank you. And a few other little things is today's talk will be available soon as a video on podcast via the Island of Ideas website, now on the UTAS screens. Beautiful. Please remember to observe COVID-safe protocols as you leave the venue. Catch a talk on one of your favorite topics. Has never been easier at home or in the office, and the series continues with the upcoming talks also now on the screen, which are up there. Island life may have changed a little, but the University of Tasmania is looking forward to keeping those ideas flowing. I also want to do a very big thank you to Belinda Brock and her team for keeping this all going online, in live now as well. It gets very confusing. And pardon my phone, hopefully it didn't cause too many feedbacks, it wouldn't go on mute. And then there is a table, RJML's out front, invitation to make a donation so that we can continue to bring these to you every year. So with that, thank you all for coming, and thank you again for Dr. Dana Bergstrom for coming along.